now it's time to talk about TPUs, Tensor Processing Units, instead of GPUs, which are graphical processing units. Okay, let me tell you what a tensor is. Tensor is an n-dimensional matrix. A two-dimensional matrix is a matrix k by n. An n-dimensional matrix is a matrix which is k by n by d by l, whatever. So why k-dimensional matrix processing unit? Because in deep neural networks, what we do is we use n-dimensional networks. Because for an image with many depths, you have n by d depth image. Or for a volume data like MIR, if you're doing deep learning of it, it is a four-dimensional matrix. So what you do is you're dealing with n-dimensional matrices. So TPU is a device similar to a GPU, which is specifically designed only for artificial intelligent applications accelerating. So these are called accelerators, GPUs or TPUs. They accelerate a specific application, which is artificial intelligence in our case. So GPUs were useful because in the very first networks, AlexNet, VGG, which are encoders, you have convolution layers on top of each other. And for the GPU architecture, well, it's nice to use them because you're doing vector operations. But for more advanced architectures, sometimes GPUs might not be sufficient because you're doing some strange multi-dimensional matrix calculations. If you have a proper accelerator hardware which is specifically designed to do it, you will get more speed. So it is like the AI version of CPUs, and it is being designed by Google. Actually, Google designed this because they are doing so many deep learning stuff in their libraries, and they didn't want to pay a lot of money to NVIDIA. They've designed this, and they are also designing one of the most important deep learning Python libraries, which is called the TensorFlow. So they've designed it specific to TensorFlow. So if you have a TPU, an individual TPU in your computer desktop, and if you're using TensorFlow, you can use it. For other libraries, it's not the same, but so Google is trying to create its own ecosystem, both in hardware and software and library, so that they stay independent and they don't pay anything to anybody, any company, and everybody is also using their system, so they pay to Google, and so Google becomes a monopoly in this. That's their vision. So they've begun using this in 2015, like 5 years ago, but in 2018, they made them available for third-party use. They started selling them. And they are very powerful, guys. Google have announced that to process all the Google Street View images for text processing, they have processed the text in every Street View image in Google Maps. All images, guys. All images in the planet. It took less than 5 days, they say. So they have a very good, nice architecture. Many devices here. So they are trying to say that they are very powerful. And about what a single TPU could do, it can process 100 million photos. And actually in Google Photos, Google is doing this in their servers with TPUs. And a single TPU, individual TPU, can process 100 million photos a day. Because in Google Photos, you're finding the faces, associating the faces with other images, captioning the images. This is a beach image, blah, blah. And the TPUs are so powerful that within a day, they can do these kind of photos. That's how they can handle everybody's photos. Okay, TPUs are very powerful and specifically designed for AI. Okay, they are tailored specifically by Google for machine learning applications. So actually, what is nice about TPUs is, you'll remember when we were discussing quantization, we said that for most networks, for AlexNet, for classification networks especially, working in 8-bit precision instead of 32 bits doesn't change much. But if you go more aggressive quantization levels like 4 bits, you lose many things. But at 8-bit quantization, you don't lose much with dynamic range. That was the outcome of the papers. We have discussed those papers. Knowing this, Google designed their TPUs for lower computational precision as well. That's how they could suppress the GPU performance. So that TPUs required fewer transistor per operations, which made them more efficient devices in power and computation. So That's why Google claimed that they can sequence more operations per second into a silicon, use more sophisticated and more powerful machine learning models, do them more quickly using less power. More importantly, they have designed these TPUs such that they can fit to data center racks, so that just like in this image, you can use tens of hundreds of TPUs altogether, because a GPU device, there are special desktops computers, you can put 8 GPUs, but I haven't seen a bigger rack for GPUs. There are bigger racks for GPUs, but TPUs are specifically designed for this rack design. You can use hundreds of racks so that you do your operations. This is one of the data centers. For example, the photo that you have taken, which was automatically in your mobile phone, which was automatically sent to Google Photos, it is being processed somewhere around here, guys. Okay, so their architecture is, in a way, similar to a GPU, but it is working hand in hand with TensorFlow, which is an open source machine learning framework. So they designed the architecture more efficient than a GPU and specifically tailored for their open source library, Python library, TensorFlow. So a tensor is analogous to a MATLAB matrix, or in Python, instead of a matrix, they have NumPy arrays. NumPy array, if you have ever used Python, NumPy array is a variable, a matrix variable in MATLAB, the basic variable. And the TensorFlow architecture is designed to process these data variables. So as GPUs were originally designed for intensive math calculations, and they speed up these kind of graphical operations, the TensorFlow does it for tensor operations. So instead of vector operations, you can do more fast tensor operations. So it is the evolved version of GPUs for deep learning. So GPUs evolved and they've become TPUs for deep learning. So a CPU has 1 to 8 cores, or sometimes 16 cores. GPU has hundreds of thousands of cores. TPUs are very similar. TPUs also have many cores. But the biggest difference is that TPUs are solely designed for AI applications, not graphics. So in their cores, they do process tensors and dimensional matrices, not vectors, just like GPUs. That's why they are faster and more efficient. And they are, as I told you, specifically designed for scalability. Scalability is you can scale different operations among different machines and TPU servers. And in these racks, you have hundreds of TPUs. You can scale those, parallelize those operations to these racks. And inside the racks, they are parallelized into cores. So a hierarchical parallelism for TPUs, which we need for deep learning. Okay, can I buy an individual TPU? Yes, guys, actually, very recently, just go to this website, they are selling it. The Sophon AI products, you can buy it, deep learning card. It's suitable for a PCI board. And if you know how to use TensorFlow, well, you can use it. It's just like a GPU, just like it's being sold just like a GPU, but it is available for use with TensorFlow. So if you're using TensorFlow and Python, just buy it, just get it in your motherboard and just install it. You can use it. Very good. Okay, so let's get to a higher level architecture analysis. So this was the CPU. We had compute primitive architecture, so implicitly managed for different processes. So this processed scalar, this processed vector. What it means is, at a single time, the CPU can do a scalar operation, multiply this number with this number. But in GPU, you do array operations. They are called GPU arrays. You do an operation with this guy, with this guy. That's why it is much faster than this guy. But in a TPU, you do an operation with a matrix within a matrix, which is not necessarily two-dimensional, n-dimensional matrix. So as CPUs evolved to GPUs to array and vector operations, GPUs evolved to TPUs for tensor and matrix operations, guys. That's why it's very fast. Okay, that's enough for TPUs. And let's talk about the FPGAs.